5.4, so this is the last unit for the last lesson for Unit 5. Today what we are doing is we are looking at what is called rational and irrational numbers. We're going to learn the difference between those. And then we're also going to be able to take square roots. And you know the square roots that are not perfect squares?
Yeah.
Like, for example, square root of 5?
Yeah.
We're going to approximate those. Okay? So, first thing we want to know is how do you approximate a square root? Okay, what does approximate mean? Does it mean that you get the exact number?
No.
No, it means we're kind of guessing, right? Okay, we're making an educated guess. Good. So what do we do when we are approximating a square root? Step 1. We want to list all the perfect squares that are near or close to the number we are approximating. So what we're going to do is we're going to list some first. Step 2, we need to pick the 2 perfect squares that are nearest, so the closest above and the closest below the number that we're trying to approximate. So we look at which one is closest, that's less than, and which one is closest, that's greater than. And then step 3, we find the square roots of those perfect squares, and that's going to give us our answer. All right. So example 1, we want to name the integers that the square root is in between. So, first of all, let's think about this. Square root of 40. Is 40 a perfect square? Mm-hmm. Are there 2 numbers that multiply by itself to get 40?
No.
No, right? How many of you were thinking 20 and 20? 20 times 20 gives me what? 400, not 40. Okay, so 40 is not a perfect square. So what we're going to do is we want to approximate it. So first thing we have to do is we need to list the perfect squares that are near what we are approximating. So what are some perfect squares that are close to 40? Audrey? 20? Is 20 a perfect square? Robert? What? 36. That is a perfect square that's close to 40. What's another one? 49. Anything else? What's one less than 36? What's the one after?
35.
What's one? No. What perfect square comes before 36? 25, right? And what's the one that comes after 49? 64. Okay, that's probably enough, right? Okay. Which 2 perfect squares is 40 between? 40 falls between 36 and 49. Okay, what's the square root of 36? 6. And what's the square root of 49? 7. So what 2 numbers does the square root of 40 fall between? 6 and 7. So that would be your answer. Okay. I'm going to check it on my calculator. Okay? So if I take the square root of 40 and I put it in, what do I get? I get 6.32455532, and it keeps going on and on. Is 6.32 in between 6 and 7?
Yes.
Yeah. I do not expect you to be able to do this. Okay? It's hard. I can't do it without a calculator. Nobody can. Which is why we are estimating or approximating. All we have to do is be able to say that it's between 6 and 7 somewhere. Okay? Okay. Square root of 11. Is 11 a perfect square?
No.
Does a number times itself give you 11?
No.
No. So we need to list the perfect squares that are close to 11. So what are some perfect squares close to 11?
4.
4.
9.
9. Is 10 a perfect square?
No.
No. Is 14 a perfect square?
Yes. 16.
7 plus 7 is 14, but what's 7 times 7?
49.
49.
16.
16.
How is 4 close to 11?
We're just listing some. And what's the next one after 16?
We're just listing like 25.
25. We're just listing some perfect squares that are kind of close to 11.
So then why
So what two perfect squares are closest to 11? 9 and 16. So what is the square root of 9?
9 and 16.
3. And what's the square root of 16?
8.
No. Square root of 16. 4. Okay, remember you guys, square root is not addition, and it's not multiplying by 2. It's multiplying by itself. Okay? So, what number is the square root of 11 between? 3 and 4. Let's check it on the calculator, shall we? Okay, so checking it on the calculator, square root of 11, 3.31662479, so on and so on. Is that between 3 and 4? Yep, so we approximated correctly. Okay. We also need to know the difference between a rational and an irrational number. Okay? A rational number is a number that can be written in one of 3 ways. It can be written as a fraction. So what would a rational number written as a fraction look like? How about 3 over 4?
What can be like any number?
Any number that can be written as a fraction. Would an integer be a fraction? So like 5, would 5 be rational?
No.
Can I write 5 as a fraction?
Yeah.
Yeah, 5 over 1. So 5 is a rational number. Okay? So a rational number can be written as a fraction. It can be written as a terminating decimal. What would a terminating decimal look like? What does terminating mean? What does terminate? It means that it ends, right? A terminating decimal is a decimal that ends. So something like 3.25. It doesn't go on and on and on. It stops at some point. We can also write a rational number as a repeating decimal. So what would a repeating decimal look like? It keeps going on, but the same number is repeating over and over, right? So something like 7.353535, and the 3 and 5 repeats over and over. Or even something like 5.6 repeating. Okay? So, what does irrational mean? Okay, you don't have to write these examples because we did our own already. So, an irrational number is a number that can only be written as a decimal that does not terminate or repeat. So an irrational number is a number that just goes on and on and on and on. So like 5.726387019, on and on and on and on. And it never repeats anywhere. Okay, so that means that it is irrational. Okay, what does this have to do with square roots and perfect squares? Is a perfect square rational?
No.
The answer is yes. Let's think about it. What's the square root of 4? 2. Can we write 2 as a rational number? Yeah, 2 over 1, right? So perfect squares are rational. What about numbers that are not perfect squares? What do you think about that? Remember how we took the square root of 11 on the calculator?
Yeah.
Okay, look at the square root of 11. It's a decimal, right? Does it repeat ever? No. Does it stop? No. It stops here, but it's actually going on and on and on, right? So is the square root of 11 rational or irrational? It's irrational. Okay? So let's do a couple examples really quick. All we have to do is be able to say if it's rational or irrational. So square root of 20. Rational or irrational?
Irrational.
How many vote for rational? How many vote for irrational? It is irrational. Why?
Because it doesn't have a number.
Is 20 a perfect square?
No.
No, so it's irrational. If it's not a perfect square, it's irrational. So what about square root of 9? Is that rational or irrational?
Rational.
Good, rational. It's a perfect square. Okay?
If it's a perfect square, it's rational.
If it's a perfect square, it's rational. If it's not a perfect square, it's not rational. Hold on, not done. Okay, 2 more. Hold on. 3 and 5/8, rational or irrational?
Irrational.
What did we say about rational numbers? Fractions can be rational numbers. So would this one be rational or irrational? Rational. What about 10.3? Rational because it terminates, right? Okay. Good.